is given with 1 or 2 pages in your textbooks. But when it comes to electrical power system, instrument transformers plays a major role uh, in coordination with relays and circuit breaker. So this is an interesting concept we have to understand. Okay, so the thing is here, all equipments together. Again, I'll repeat again, each and every equipment, guys, here. Fuse is the one-time usage device, as you know very well. So fuse is a very good protection and controlling device. And a breaker will discuss. Don't worry. I'll take through all the equipments here. I'll explain you very clearly. So I'm just giving you the brief introduction about these components here. So circuit breaker is the switching device which is used to control the system and to isolate the faulty section from the healthy section also we can say. And instrument transformers are used for all the protection and metering purpose. All the meters and relays are going to connect across the instrument transformers, guys. And the contactor is also electromechanical device, and the isolator is the offload switch. Isolator, we call it as a offload switch because of isolator cannot be used under loaded condition because of it doesn't have any making and breaking capacity. This is all about the brief introduction about all the components here. So now let's see. Yeah. So
Madan sir, could you please give me 1 minute? Please don't mind.
yeah, thank
You're
you.
not allowing me to do the work.
So guys, just be connected for a few
You can
seconds.
share your screen, sir, now.
Thank you so much. Yes, guys. Okay. See, now the point here is the reason behind showing this all the components here is generally I just want to picture as like, can anybody tell me like what is this equipment, guys? What is this component? Can anybody tell me in the chat box? What is this components? Can you name this component? So it is very easy, I think, for you people. Yes, you're right. This is exactly the name we have to spell. Is not normal fuse. It's an HRC fuse, like high rupturing capacity fuse, we call it as. And yes, what is this component, guys? What are these components? Can anybody tell me? Yes, it's a combination of different circuit breakers. You can simply, I think most of the people are giving me the answers like MCB and all, but we have different circuit breakers here. This is called MCB, and we have this is an MCCB and all. We'll see that each and every. These are all the group of circuit breakers we use for low voltage applications. Okay, so I'll just show you the next component here. Can anybody tell me what is this equipment? What type of relay is this? I think you could have seen this relay in your labs, right? So especially I'm talking about this relay. Okay, what type of relay is this, guys? What type of relay? Yes. Okay, so it's like electromagnetic induction disk type relay. You can see the disk over here. So this is the relay. Okay, these are like this is like a electromagnetic induction disk type relay, and this is a static relay, we can say. And what type of relay is this? We can call this relays as a numerical relays. Already we mentioned here. So you have like a HMI interface, and you have all the digital display and all. So the latest ongoing relays we are using in electrical system is this relays. Okay, so and the next equipment I just want to show you, because the point why I'm showing you all these pictures, by looking at the component, you should be in a position to identify the component. That is very important. Okay, so can anybody tell me what is these components? Yes, yes, you're all. I really appreciate your prompt answers, guys. So especially we can call like these cities are this is a tape wound city, we can call it as, and these are called resin cast cities. Okay, the insulating material is a resin cast. Okay, and this is like a oil filled cities. Like we use all these tape wound and resin cast cities are used for the indoor applications, and this oil filled city is used for the outdoor applications. Okay, nice. I'm very happy for your great response today. So the point here is, now there is a big question. Like generally, why I'm asking this question here is like when someone asks me the question like, what do you mean by circuit breaker? Okay, so generally people say the answer in your, because you learn in your academics like breaker is a switching device which can isolate the faulty section from the healthy section by taking inputs from relay. This is what the answer you are going to give. But the point is, you must have the clarity, because unless until you understand the relation between breaker, CT, and relay, you cannot understand the importance of each and every equipment here. So people think that like you like a what is the purpose of using circuit breaker, and what is the purpose of using current transformer and a potential transformer and relay. So and how these equipments are coordinating in isolating the faulty section from the healthy section. So that I'm going to make you understand in a very simple way with a simple diagram, guys. So I'll just show you here. Generally, what happens, as I told you, like here, this is a circuit breaker. CB stands for circuit breaker, and this is the current transformer, and this is a relay coil. So what happens here when fault occurs in the system? Generally, what should happen? For example, if this is your incoming feeder and this is the transformer, if you just say like this, and these are all few outgoings are connected to the bus like this. So when fault occurs in the particular outgoing, what should happen? Only the faulty section shall be isolated from the healthy section. Okay, because of this fault, altogether, you people are learning a new concept, I'm telling you. Okay, when fault occurs in the particular feeder, only the faulty section should be isolated from the healthy section. So remaining outgoing feeders should not get disturbed. That is a concept in electrical system. So because of this fault, if this breaker is opening, then what happens? All the outgoings are going to disconnect. So it means your system doesn't have any stability. So to make this happen, so proper coordination between circuit breaker, CT, PT, and relay is required. Unless until we are using proper equipments in electrical system, the faulty section is not going to clear effectively within the timelines. So now, to make you understand that, I'll just tell you, like when fault occurs here, what happens? First, I told you like instrument transformers plays major role in electrical power system. So instrument transformers, what happens here? So generally, this is a CT. So your CT ratios will be, it will be like 500 bar 1 amps or something, whatever. So what do you mean by this? When 500 amps current is flowing in the primary, your CT will just step down the current in the secondary winding 1 amp. So when everything is going normal, obviously what happens, like when 500 amps is flowing in the primary, CT will give you 1 amp in the secondary. Then obviously the relay will not operate. So when the relay will operate, if the current is going to flow more than the full load current. For example, yesterday we discussed, for example, if this is the transformer and we have seen like a 132 by 33 kV transformer, 50 MVA. So what is the full load current at 132 kV side? Can anybody tell me what is the full load current at 132 kV side, 50 MVA transformer? Yesterday we have seen like the 33 kV side, the current was 872 or something. I didn't remember properly. Okay, now you have to tell me the peak values. Like if 862 or 872 is the 33 kV side, so 132 kV side, the current will be by 4. Because when the voltage increase by 4 times, current is going to reduce by 4 times. That is the logic you have to catch over here. That's where you will become like ahead in electrical engineering. So 874 amps is the 33 kV side. I'm talking about 132 kV side. What is the full load current at 132 kV side? So what is the answer, guys? That is very important. That is the reason I took the class yesterday on electrical basics. So 218 is the right answer. Okay. So obviously what happens here? When the current is flowing through the CT, here what I'll do, if 218 amps is the right full load current, I'm going to take the CD ratio, like it will be 250 bar 1 amps. I'll tell you like how to decide the primary current, secondary current. So under the normal condition, what happens when 218 amps current is flowing in the primary? So ratio times the CD will give current to the relay, then your relay will not operate. So then what is when the problem will occurs? That is very important. So when fault occurs here, obviously the fault current will be in kiloamps. Okay, your fault current will be like a 10 kiloamps or 15 kiloamps or 20 kiloamps, 40 kiloamps, depends upon your network, depends upon the grid condition, all this stuff. So obviously, when fault occurs, if the fault current is, for example, I can tell like if 5K is a fault current. When your fault current is 5 kiloamps, then can anybody tell me what is the CT secondary current? When your fault current is 5 kiloamps, what would be the CT secondary current? So obviously your CT secondary current would be ratio times. Understand? When 250 amps flowing in the primary, 1 amp will be the secondary. When 5000 amps means obviously like 20 amps will be your CT secondary current. So when under the fault condition, when the same fault current is given to the relay, here the point is every relay has some NO contacts and NC contacts, normally open and normally closed contacts. So when your relay is under normal condition, NO will be NO means normally under normal condition, it will be NO and NC. So what you should understand the block diagram here given here. So what we have given here, the relay NO contact. This is the NO contact. The relay NO contact is connected in series with the breaker tripping coil. This is the tripping coil of the circuit breaker, guys. And this tripping coil, see, when the tripping coil energizes, your breaker will open the contacts. That is a simple. Like in the circuit breaker, you have closing coil and tripping coil. So when the tripping coil is going to energize the tripping coil, it is connected with a battery. So battery will give the DC supply. This is like we need continuous supply for the tripping circuit of the circuit breaker. So under the fault condition, what happens here? I'll just tell you. When fault occurs here, the CT gives fault current to the relay. So based on the given CT input, the relay is going to operate, guys. When the relay operates, what happens? The respective NO becomes NC and your NC is going to become NO. NO becomes NC, NC becomes NO. This is the funda of relay, simple. So, when this NO becomes NC, what happens? This NO is going to be closed. So when this NO becomes NC, current always flows through the closed path. Current always flows through the closed path. When this NO becomes NC, this path becomes the closed path, then the tripping coil of the breaker is going to energize. When the tripping coil of the breaker energizes, your breaker will just open its contacts. That's how the faulty section will be isolated from the healthy section. So this is the coordination between circuit breaker, current transformer, potential transformer, and relay. So we have so many equipments in switchgear family. But the close family members in the switchgear family is circuit breaker, CT, PT, and relay. These are the close family members. You can say like breaker is the father, and relay is the mother, and the CT, PT is the son and daughter, like that. I can just redefine in such a way. Okay, I will give you the example because here breaker is the switching device. Circuit breaker is a switching device which can isolate the faulty section from the healthy section by taking inputs from relay. When fault occurs, the relay will give input to the circuit breaker to open its contacts to isolate the faulty section. How? When relay operates, the respective NO contact will become NC. That's how it will energize the breaker tripping coil. When the breaker tripping coil energizes, circuit breaker is going to open its contact. This is how circuit breaker can isolate the faulty section from the healthy section under abnormal conditions. So that's the reason, like relay is the sensing element, relay is the sensing device, breaker is the switching device here. Okay, and the remaining CT and PT is going to give input to the relay. To sense the abnormal condition, the relay will take inputs from CT and PT. CT will give the abnormality of current, and if there is any voltage related abnormality, that input will be given by the PT, potential transformer. This is the relation between circuit breaker, CT, PT, and relay. Now the point is, so if you want to design, you see the point here is, this is very important to select these equipments. What is the selection criteria of breaker? What is the selection criteria of CT? And what is the selection criteria of relay? Because if your breaker and CT is healthy, but your relay is not healthy, then what happens? When fault occurs, even though CT is giving input to the relay, so relay cannot operate. When the relay cannot operate means its NO is not becoming NC, then the respective tripping coil for the circuit breaker will not energize, then your breaker will not open. Obviously, the faulty section will not be isolated from the healthy section. So here, my point is the selection of these components, the selection of circuit breaker, selection of CT, PT, and relay plays vital role in maintaining the healthiness of the system. So for that, what we have to do now, we should understand like what is circuit breaker, what is current transformer, what is potential transformer, and what is relay. That is very important in terms of switchgear concept. So let us understand, like first we'll go through the circuit breaker. After that, we'll just understand what is instrument transformers, and finally we'll just understand what is relay, so that you will understand the importance of these 4 equipments in electrical power system, guys. So now let's start with the first question. What is circuit breaker? As I told you now, circuit breaker is the switching device. So I can tell you like a circuit breaker is a switching device which can isolate the faulty section from the healthy section under abnormal condition by taking inputs from relay. That's what I explained in the block diagram. So how this relay is giving input to the circuit breaker. So you should think in a very simple way. Wherever you have the circuit breaker, definitely you have the CT and the relay over there. Okay, if your circuit breaker is being alone, then there is no one to give input to the breaker. So whenever you have the switching device, definitely we should have the sensing element also. Then only when fault occurs, so the fault will be sensed by the relay with the help of CT and PT. Then that relay will give input to the breaker. So this is a simple common funda we have to understand. So now this is what the breaker, circuit breaker is a switching device. Now breaker can make and break the circuit under normal and abnormal conditions. So this is what about the breaker. Now we have to understand what is the classification of breaker, like what type of breakers we use in electrical system. Okay, classification of circuit breakers based on the voltage levels. Okay, because if you define the voltage levels, we have like a low voltage, medium voltage, and high voltage circuit breakers. So up to 1.1 kV, we call it as a low voltage, and 3.3 kV to 33 kV we consider as a medium voltage, and above 33 kV. Above 33 kV means generally above 33 kV comes under like a 132 kV, 220, 400 and 765. These voltage levels we consider above 33 kV, those we call as a transmission voltages. So depends upon the voltage level, we generally consider the circuit breaker. So now let us see what are the breakers we use for low voltage, medium voltage and high voltage applications. So guys, I want to clear one point here, because this switchgear concept and this breaker instrument transformer relays concept is very huge concept, guys. Okay, so within the given timelines, I'm just trying to give you the glimpse on these equipments. If you want to understand, get expertise on these concepts, so you have to join with our regular industry-based job-oriented training. So there we are going to make you understand in detail about all these equipments. Okay, so here if you take the low voltage circuit breakers, so we use like these are the breakers we use for the low voltage applications, like a MCB. MCB stands for miniature circuit breaker. MPCB stands for molded case circuit breaker, and MPCB is the motor protection circuit breaker, and ACB stands for air circuit breaker. So when low voltage comes into the picture, you have to keep this in mind. Okay, for low voltage applications we use, and I'll just show you how the MCB looks like. So these are the MCBs: single pole, double pole, triple pole, and four pole MCBs. And the technical specifications of MCBs, these are very, very important points I'm telling you guys. So you please note down the points if possible, because everybody knows about MCB, but nobody know like the micro level understanding about the low voltage circuit breakers. So generally MCBs are available. The current range of MCB is available from 0.5 amps to 125 amps, and the maximum short circuit withstanding capacity is available for MCBs up to 12 kilo amps. Mostly we use MCBs for the distribution loads. DP is a double pole. Okay, so number of poles available for MCB is like SP stands for single pole, double pole. This is a double pole. This is a single pole. Triple pole in the sense like you have like RYB is connected like this. RYB is connected. Four pole is like RYB and N is connected like this. And double pole is only phase and neutral is connected. Single pole is only phase is connected like this. Okay, so and the inbuilt protection provided with the breakers, all MCBs provided with a overload and short circuit protection, guys. So this is what the brief about MCB. So now the point is, MCBs are, what is the limitation of MCB is available only up to 125 amps. So if the current is more than 125 amps, if it is a low voltage application, and if it is more than 125 amps, then what type of breaker we use? Okay, so there is like a necessity creates invention. And if the fault level is more than 12 kilo amps, then we should have some other equipment. And so for that, we have one more breaker we use for low voltage application, that is molded case circuit breaker, guys. So these are the various series. This is a LNT circuit breaker. Okay, we have different series of breakers, depends upon the current range available. Okay, the current range available for MCCB. MCCB stands for molded case circuit breaker. So molded case circuit breakers are available from 20 amps to 1600 amps. Means it starts with like a 20 amps, 32 amps, 40 amps, 50, 63, 80, 100, 125, 150, and 200, 250, 300, 350, 400, 500, 630, 800, 1000, 1250, and 1600. These are the standard ratings of breakers available in the market, and the maximum short circuit withstand capacity of circuit breaker is available up to 50 kiloamps. Nowadays, there are few manufacturers who is giving up to 65 kiloamps MCCBs also available in the market, maybe with ABB or Schneider and all, that you can check with the respective manufacturers for the maximum short circuit withstand capacity. And the MCCBs are available in the form of TP, TPN, and 4-pole, guys. So what does it mean, TP, TPN, and 4-pole? In the sense, MCCBs are used only for three-phase applications. Okay, MCCBs are used only for three-phase application, and MCBs can be used for single phase and three-phase. That is for MCB. So MCCBs are used for three-phase and single-phase application, guys. So now the point is, we have one more breaker in the low for the low voltage application, that is ACB, air circuit breaker, guys. So MCB, MCCB, and ACB. These are the three breakers we use for low voltage applications, in the sense up to 1.1 kV. Up to 1.1 kV voltage levels, we use these three breakers: MCB, MCB, MCCB, and ACB. These three breakers are used. So now coming to ACB, air circuit breakers. So what is the MPCB is used for the motor protection applications. Only for the motor protection applications we use MPCB, guys. It has a special application for motors. Okay. So current range available for ACB is like 800 amps to 6300 amps. And the maximum withstanding capacity, the short circuit withstanding capacity of ACB is available up to 100 kiloamps. And the number of poles, like ACB is also available in the form of TP, TPN, and 4-pole. So, and ACB is, see, here you have to understand in terms of inbuilt protection. Generally, for low voltage circuit breakers, we have the inbuilt protection. Means all the low voltage breakers are provided with the inbuilt protection. We cannot go with external protection for the low voltage application because it will become very costly. Okay, so all the low voltage circuit breakers provided with within the breaker we have the protection. So what is the protection is provided with ACB, like a overload, short circuit, and earth fault. So overload and short circuit is like if the current is greater than 1.1 times of your full load current, that comes under overload current. We call it as. Short circuit is like if the current is flowing through the equipment more than 3 times to your full load current. So that we consider as a short circuit current. Okay. So this is again, comes again a different in depth into the concept. Okay. So when time comes, I'll definitely explain in depth into this one, overload, short circuit, and so ACBs are available with its inbuilt protection of overload, short circuit, and these are the ratings available for ACB, starting from 800 amps to 6300 amps. So now you have the doubt here. Maybe, sir, for example, I can ask you one question. 1000 amps is there. 1000 amps MCCB is there, and you have ACB is also available. So which breaker shall be selected? Understand? When both the breakers are available for 1000 amps, which is the right selection? Generally, what we do is ACB is used in the incoming feeders. If your application is the incoming feeder, we generally go with from 800 amps and above. All the incoming feeders, we go with ACB. And for outgoing feeders, we prefer to go with the MCCB. So to design a cost-effective solution, we generally go like this. There is a reason for that. Why we go only incoming feeders like this? Because there is a concept called interlocking. There is a concept called interlocking. We have like mechanical interlocking, and we have like electrical interlocking. So if you want to go with electrical interlocking, that is possible only with ACB. So if you want to go with the mechanical interlocking, then we can go with the MCCB. So it depends upon the application. We generally go which breaker shall be used. Okay. So this is about low voltage circuit breakers, MCB, MCCB, and ACB. And we use for the medium voltage applications like a 3.3 kV to 33 kV. We generally go with a vacuum circuit breaker. Generally, from 3.3 kV to 765 kV, we have SF6 circuit breakers, and 3.3 kV to 33 kV, we prefer to go with the vacuum circuit breaker. There is a reason for that. Because this 3.3 kV to 33 kV is a medium voltage application. And here what happens in the medium voltage distribution uh, segment, the number of breaker operations like open and close operations will be more. And because of that reason, if you are going with SFC circuit breaker, it will be like the maintenance will be very huge because you have to maintain the gas pressure in the SFC circuit breaker. As we have more number of operations in the distribution system, so instead of going with SFC circuit breaker, going with a vacuum circuit breaker will be more optimum solution. That's the reason. And coming to this, like within the less given space, VCB plays like see the major reason going with the vacuum circuit breaker is like vacuum is a arc interrupting medium. Okay, so within the less space, vacuum circuit breaker, if you are going with the vacuum circuit breaker, it can interrupt the arcs effectively. So that is the reason. For you just remember here, for 3.3 kV to 33 kV, we generally go with the vacuum circuit breaker. And for a transmission voltage levels like a 132 kV and above, generally the fault level for I said like a 3.3 kV to 66 kV, we go with the 40 kA. This fault levels depends on the manufacturer recommendations and your requirement, guys. So generally, SF6 circuit breakers are used in the system for 132 kV and above. Okay. So for 132 kV, 220 kV, all these applications, we prefer to go with SFC circuit breaker. We had so many breakers, oil circuit breakers, air blast circuit breakers and all. So due to their heavy maintenance and failure ratings and all, now SF6 circuit breaker is playing a phenomenal role for the transmission applications. So you just remember, for low voltage applications, we use MCB. We have like a MCCB and a ACB. And the medium voltage applications, we go with a vacuum circuit breaker. And for 132K and above high voltage applications, we generally go with the SF6 circuit breaker. Okay. So here, I just want to show you the video, like how the breaker is going to operate, guys, here. So just be connected. I'll just show you the SFC circuit breaker operation, how the breaker is going to operate. This is a ABB breaker. Okay, it will just give you great idea about how the breaker will operate. See, actually, this is a huge concept. Okay, within the given time, making you very in detail is quite difficult. Just listen to this. This is a spring charging mechanism, guys. Okay. Close and open the breaker. It will give you the required kinetic force to move the moving contacts and fixed contacts. Now the breaker is getting open. So this is how vertical operation of the circuit breaker. This is how the breaker will operate. So once we understood about the circuit breaker, so I'll just give you some glimpse on instrument transformers. Like the next, this is the current transformer and this is the potential transformer, guys. So this is like before going to understand what is instrument transformers, first you should be clear with a transformer. Like as you know very well, transformer is a static device which can step up or step down the voltage without changing its frequency and power. So here there are different types of transformers like a power transformer, distribution transformers and all. So the same way like instrument transformers also one of the type of transformers. Majorly we use instrument transformers since we connect all the measuring and protective devices across the city, because for the meters, for all ammeter, multifunction meter, kilowatt hour meter, so you cannot directly connect these meters and relays to the line as it has like a higher currents. These meters and relays cannot withstand for the higher current. So the operating current of the meters and relays will be hardly like a 1 amps like that. And so due to that, we connect all the meters and relays across the instrument transformers. So any meter or relay is required current input is connected through CT, and any meter or relay is required voltage input that is connected through PT. So we have two types of instrument transformers, current transformer and potential transformer, guys. So here, this is like, what are the standards we follow? I told you like this, everything we are going to design the system as per IS and IEC standard. So the CT, the IS standards for CT will be current transformer will be IS 2705, and IEC stands for International Electrotechnical Commission. So IEC standards we follow 60044 part 1, 2 and 3 will be for CT, and highest standard for PT will be like 3156. And I see, if you join with our regular training, we are going to give you all the respective IS and IEC standards, and we will make you go through the standards, and we will make you understand the concept as per IS and IEC standards, guys. So here, this is what like the CT is an instrument transformer where which step down the current to the rated value of connected instruments, and this is the symbol, the graphical representation of CT as per IS standards. So if it is a IEC standard, generally we represent the CT like this. This is a three-phase CT. So here the current flow of direction, if the primary side the current is flowing P1 to P2, secondary side current will be like a S2 to S1. This is called the CT polarity. This is very important in connecting the relays across the CT secondary. Okay, CT polarity plays a major role. So this is current transformer, guys, and these are the few CTs. Like this is a tape wound CT and this is oil filled CT. Okay, these are all different CTs we use for the various voltage levels. Okay, so the next we need to understand the most important point is relay, guys. Okay, so we discussed about circuit breaker and current transformer, and we have to understand, we discussed about father and son. We have to discuss about mother here, because relay, what do you mean by relay here? Relay concept is a huge concept. Okay, so generally relay is a sensing device. You have to understand one thing. Breaker is the switching device. Breaker is not the protection device. Breaker is only controlling device. So breaker will control the system by taking inputs from relay. And relay is the sensing device. How the relay is sensing the abnormal conditions? By taking inputs from instrument transformer, that is current transformer and potential transformer. That is, I clearly explained in the block diagram. Okay, so it is mentioned here which can sense the fault by taking input from the CT, and it will give signal to the corresponding breaker to isolate the faulty section from the healthy section. So here the relays we have like this is what I explained so far. Okay, this is a three phase, like a three line diagram. That was the single line diagram we can interpret like that. Okay, so generally we have different functional requirements of relay, like a reliability, selectivity, sensitivity, and speed. When you are selecting any relay, we have to check all these functional requirement, guys. And we have different relays. The relay classification, relays started with electromechanical relays initially, and because of its reliability, sensitivity, and speed, obviously when any equipment is introduced, people are doing R&D in terms of its operation, reliability, and all. So when people are using electromechanical relays, there was the electronic revolution. So by using like a diodes and transistors, people started manufacturing static relays. Static is nothing but there is no moving part, very simple. And after that, by using thyristors and microcontrollers and microprocessor, people started using digital relays. And up to digital relays, all the relays are single function relays. The major difference between digital relay and numerical relay is a multi-function relay, guys. Okay, multi-function relay in the sense within the relay we have so many functions. Like if you take like a P545 is a relay model, Schneider, it has like a overcurrent at fault, directional overcurrent at fault, differential protection. So we have like a different types of functions available in one relay. That is the specialty of numerical relay. So actually, within the given timelines, covering this huge concept is really a tough task. So these are the electromechanical relays, because one relay, one function. Because of that reason, you can see many relays in the relay panel. But nowadays, if you go through any any substation cylinder panel, you will see only one main relay which has all the functions. These are all electromechanical relays, and induction discharge relays like this. This is a static relay, and this is the numerical relay algorithm will be like this, which has like a SCADA interfacing with operation speed is very high, and you have great reliability and stability for the numerical relay, guys. So the point here is, today we have our guest speaker, Mr. Banavas Reddy. He is the Deputy General Manager for Toshiba JSW company. Like I just want to invite Mr. Banavas Reddy to make you understand further. He will take this session further to make you understand about all this concept, like how these switchgear concepts would be more useful in the real-time environment, guys. So I request Ms. Kavya to invite our today's guest speaker, Mr. Banvas Reddy. Thank you so much.
Yes, sir. Thank you, Madan sir, for the wonderful insights on switchgear concept. I would like to welcome Mr. P. Banuvas Reddy sir, who is currently working as Deputy Manager Electrical in Commission Department of Toshiba JSW Power Systems Private Limited. He has around 19 years of experience in testing, commissioning, maintenance of various combined cycle and coal-based power sector projects. We are very honored to have you over here, sir. Please enlighten us with your industry pointers relating to switchgear. We welcome you, sir.
Thank you, Ms. Bhavya. Can you hear me?
Yes, sir. We can absolutely hear
You can
you.
continue.
So you can turn on your video also
Okay.
and share your screen also.
Hi
sir.
everyone. Can you hear me?
Yes, sir. We can hear you.
Okay. Now Mr. Madan Mohan has explained about the switchgears theoretically. Just I wanted to show one typical thermal power plant switch single line diagram so that I can understand how where the CTPT solve will be used in real time environment. And now I'm going to share my screen and try to explain simple single line diagram of one thermal power plant. Can you see my screen? Can you?
Yes, sir. We can see your screen. You can go
Oh,
ahead.
okay, okay. This is typical thermal power plant single line diagram. Uh, this is generator, and these are transformers, and this is called generator transformer. So when the generation after generation, the generating transformer, the power is will be fed to a generating transformer, and further this will be connected to the switcher. This generating transformer is a step-up transformer to that will be step up the generator voltage to the transmitted voltage like 400 volts, 765 kV, 400 kV and 765 kV like that. And this is generated, and you can see these two tappings going to two different transformer. This is called unit transformer, and this is called both are unit transformers only, one like a main and standby. This is unit transformer A and unit transformer Bombay, and this will be used for the plant auxiliaries, whatever motors, pumps, lighting, whatever plant utilities are there for generating the power. There we can for that purpose these two transformers are will be used. But before generation there will be no power here. So for startup purpose we will use this standby transformer initially. From uh, from switcher we will connect this transformer, and from other grid we will take incoming supply to the standby transformer. This is called standby transformer, startup transformer, whatever it is. Some places this can be called as station transformer. This station transformer will be fed to the station switchgear will be there. From there this is breaker, and this tie-up will be there to the unit transformers. You can see this is going to here. This is also one transformer. This is station transformer 2, and this is station transformer 3. This is standby transformer. This is for some other purpose. This is 130 kV transformer. This is actual station transformer. From here two windings are coming. You can see we will feed this through station switchgear, 11 kV switchgear. From there one tie breaker will be there. This is called tie bus duct, and this will be fed to the unit switchgear. Actually this has to be fed in normal condition from the unit transformer, but before generating there will not be any power, so we will take from the station transformer the power supply and feed to the station switchgear, and from here we will give it to the unit boards. These are all 11 kV boards. From here further distributions will be there. These are by depending on the our auxiliaries rating, the switchgears will be decided. Further that should be stepped down to medium voltage system, or directly to the LT switchgear, LT system. This is medium voltage system 3.3 kV, and some other drives and auxiliaries will be there, and like that only here the transformers, step down transformers are there, which are converting the 11 kV into the 415 volts. If you have any doubts, you can ping me in chat.
see here, you have to observe like every stage, like what are the different types of switch gears we're using, like breakers and relays. I think Banu, you can explain like what are the relays and breakers we're using in this SLD, so that could help
Okay,
them
okay,
understand
okay,
better.
okay. In this, they have not given CTPT drawings. This is not protection drawing. This is simple power flow drawing. So it is,
Yeah,
and
yeah.
they have not given single line in this. I will try to show one more thing. 1 minute.
Sir, no problem. I think we can continue with question and answers.
Yes, if you have readily available, you can share the drawing for 5 minutes.
Okay, we
Okay.
have a question. So why do we use NGT?
I think it's a time to answer participant questions, because there are a lot of questions in the chat box. So we'll address the questions, Banu. That is
Okay,
better.
okay, okay.
Uh, Sir, I'm stopping your screen sharing.
Yeah, yeah, yeah.
Thank
I
you.
say.
Right. So we have a question. You can start. You can start your video, sir. Students will have questions and you can answer them. First
Okay.
question. Why do we use NGT? Question from Mohan. Okay, you got my question, sir? Okay, there's another question from Sai. How does CT reduce the current?
See, CT is like a current step down transformer and voltage step up transformer, guys. Generally, what happens, like yeah, this will follow the current balance equation, like I1 by I2 is equals to N2 by N1. So we, based on the number of turns, like we provide, for example, if the CT is 500 bar 1 amps, so primary winding will have 1 turn, and we have like a 500 turns in the secondary winding. So that's how, when the number of turns increases, your voltage will increase, EMF will increase, so that current will reduce. So that is the operating principle behind current transformer.
Okay, there's another question. Both the auxiliary transformer with standby implant. Okay, Rambabu, the question is not clear.
Uh,
Yeah. Why a lot of transformer are used in the drawing? Question from Arun.
a lot of transformers with the different applications and different locations that will be there. And a thermal power plant means that is 200, 400 acres land will be there. So many pump houses, so many auxiliaries will be there, different location. We need to transmit the voltage. So LT voltage we will transmit with longer distance, means the voltage drop will be there. So that's why we'll transmit that voltage in 11 kV format to different auxiliary locations. So that is LV transformer. And in HT main plants also, some big drives will be there, like MDBFP. MDBFP means main motor operated boiler feed pump. Only that pump motor megawatt rating is 14 megawatt is there. That is operated by 11 kV. And some condensate extractor pumps, some other auxiliary pumps will be there that are more than 300 kilowatt, 350 kilowatt motors are there, that should be operated with 3.3 kV. So again, we need to step down that voltage. Like that, so many applications are there. Depending on the applications, the transformers are used. Number of transformers.
Right. So there's Tarun, you can unmute and speak. Ask your question.
Good evening, sir.
Hi, good evening, Lindy.
Yes, sir. Sir, I heard about the CT, the secondaries of the CT should be short, sir.
Yes.
Why, sir?
See, actually, yeah, the driving function of the CT is primary winding. Generally, what happens if you are not, see, under the loaded condition, if the CT secondary terminals are being open, what happens? The high voltages will develop in the secondary winding, because CT, irrespective of connected load, when the primary current is flowing in the primary winding, the same ratio of current will be given in the secondary winding. So it will build high voltages in the secondary winding. So it leads to insulation failure of the CT. Okay, CT will damage. Very simply, I can tell like that. So instead of happening like that, if you you have to short the CT secondary terminals under like a no load condition. Like if your CT is being open, high voltage will build in the CT secondary winding. So to avoid the CT damage, we have to short the secondary terminals and connect to the ground. So whatever the voltage develops across the CT secondary, that will drain to the ground, so that you can avoid CT damage.
Yeah, thanks, Tarun, for the question. Madan sir, if we give time now, you will start talking about CT just by on the screen.
It's a big
So
concept
Tarun,
actually.
yeah, Tarun, I
So
request you
by
to
keeping the timelines in mind, I'm just giving you short answers, guys. Uh, like you are asking a 10 marks question for 10. You're asking 1 mark question for 10 marks answer. Okay, but anyway, I'll try to give my best. Okay.
Okay, so before we continue with the next set of questions, guys, we do have our next batch starting on September 23rd of this month. I mean, so that's a job-oriented course program where you will be trained and then get placed. Our course duration is for 2 months, and we will be training on electrical system design. So I request all of you, if you want to inquire for the more details, contact us, and our information is being given on the chat box. So moving on to the next question from Vasanta. Difference between NGR and solid earthing.
NGR is for restricting the earth fault current. Solid earthing is there is no restriction for earth fault.
Okay.
Earth fault currents, if you want to restrict the earth fault current to some level, then NGR will be calculated according to the engineering calculation. The earth fault current will be restricted to some extent. That
Right, sir. There's a question from Akash Babu. What is drought and non-drought type of circuit breakers?
circuit breakers or drought type means some breakers are only fixed type. You cannot draw out the whenever you want. That is fixed voltage, fixed like that. Okay, you cannot simply rack out and maintain the breakers or give service to the breaker online. Whenever you want to do the work, you need to take the shutdown of the breaker. Then only you can repair the breaker. In drought system, the power terminals and control terminals are fixed somewhere, and some sliding contacts also there in breaker. Whenever you draw the breaker will come out, the power terminals will be there. In that case, the shutdown is not required for the panel. In running in live condition also, we can withdraw that. But breaker should be in open condition, not in closed condition. Whenever you draw out the breaker should be open. That should be ensured. In closed condition, breaker
mainly
should
that
not
is
be
for the
drawn out.
maintenance flexibility.
Yeah, maintenance flexibility.
Thank you, sir. What is the difference between SSR and relay? Question from Tarun.
SSR.
Okay, Tarun, can you please be clear? I would like to understand
What do you mean by
SSR.
SSR?
Yeah, there's a question from Pravina. We'll move on to the next one, sir. What is IS and IFC?
Not IFC, that is IEC.
IEC.
IEC is the Indian standards. IEC is the International Electrotechnical Commission. Generally, when you are working in international projects, people follow IEC standards. For the Indian projects, generally we follow IS standards.
Right. There's a question from Sakshi. Can you explain Buckle's relay? Sakshi, maybe we can come on another session to talk about Buckle's relay and the transformers in detail. Sorry, we are not answering it right away, but Buckle's relay is a gas-operated relay that much I can tell you right away. Then we have does relays are used for motors also? Question from Sheikh Feroz.
Yes, of course, we use relays for motors. For the megawatt range motors, we go with the motor protection relays. Generally for the low voltage motors, we use overload relays. Depends upon the motor rating and motor application. We generally go with the different relays.
Right. Mohan, you can unmute and speak up.
Good evening, sir.
Hi, good evening.
Sir, normally in every instruments, something like CT, PTs, and transformers are there, no, sir.
Okay.
On them, the class will be mentioned, no, sir. 0.5 or a 3P or 3P, like that will be mentioned.
Yes,
So what
yes.
is that, sir? Means what is
See, that actually, whatever you said, 0.2, 0.5 and all, it represents the metering class of the CT. It means, for example, if it is a 0.2, 0.2 represents the ratio error of the CT, 0.2% of the ratio error. If it is like generally, if it is class 1 is 1% of ratio error. It represents ratio error of the CT. And coming to 3P is a protection class for potential transformer. So 3 is the 3% of voltage error, P stands for protection, like that.
Right. Thank you, Mohan. Shravani, you can ask your question. Shravani, you there? Okay. Ishwar, you can unmute and speak up.
Good evening, sir.
Yeah.
Hi, good evening, Andy.
Sir, why do relays operate in substations, sir?
Mhm.
And what is the capacity of the relays?
Relay operate only under abnormal condition. See, depends upon the relay. For example, if you are using overcurrent and net fault protection relay, so if the current is flowing more than its rated value, then the particular relay will operate and it will trip the corresponding breaker. Okay, so we don't have any ratings for the relays. So relay is a relay. Okay, depends upon its specific working conditions. The relay is going to operate by taking inputs from the respective CT and PT. That's it.
Thank you, Ishwar, for the question. We have a question from Aditya Vardhan. We're saying ST is a transformer which is a connection to the station to get the power from the outstation when the plant is at shutdown or overhauling. And it is a unit transformer which is used for running and auxiliaries in the plant, which are
This is a
essential to
question or
run.
answer?
No, it is a question.
Okay.
Okay. Which are essential to run when the plant is running or not. So maybe his question is where the station transformer and where the unit transformer are used, or in terms of
Sta-
auxiliaries. Yeah.
Okay. Station transformer is now we are going to put one power plant. So there is no power for commissioning the power plant. We have so many drives. We need to run the boiler. We need to drive the motor. So we need power supply. The two reliable power supply we need. So on station transformer, you can say standby transformer. You can say so many people different name. The transformer will be there. From grid we will take power supply for the transformer, and that will be fed to our HT switchgear. Further distribution will be there. Before generation this will be there. After generation UTs will coming line. So this will be bus transfer schemes will be there. That is a huge concept between UT boards and ST boards. Bus transfer schemes will be there. Whenever the generation will come, after 30% or 40% load will come, then our UTs will come online. I mean, we will take manually UTs will come in line with using bus transfer schemes. And standby transformer will also will be online, but some part of the auxiliaries only that will be main auxiliaries will be fed by the unit transformers.
Thank you, sir.
In,
Then we
in
have a
case of
question.
unit transformer failure, also if generator trips in with any fault, at that time bus transfer scheme will immediately change over the supply to the from the ST to UT boards, so that no auxiliaries will be tripped. That is the purpose of ST and UT.
Thank you, sir. Then we have a question from Sandeep saying, can we use auxiliary relays in addition with the main relays? In that case, what type of auxiliary relay to be used?
Auxiliary relays, main relays are for protection purpose. That is designed for protection or specific protections, under voltage protection, over voltage protections, whatever protections, different protection, different relays will be there. That was protection relays. But protection relays will not be having sufficient. Sometimes protection relays will not be having sufficient context to give feedback. Some some people will ask, I want feedback in control room. Some people will ask, I want annunciation. Like that, so many requirements with it. Then NONC auxiliary context is not available sufficiently in relay. parallelly we will use auxiliary contacts, multiplication contacts, contactor, we can set multiplication relay like that. Their auxiliary relays are common. Any relay can use auxiliary relay, but protection relays are specific for protections like that.
Yes, sir. Then we have a question from Irfan Sheikh. What is the difference between live tank CT and dead tank CT?
Live tank, see, the point is that is depend nowadays all the cities are live tank cities only we are using. Okay. In the older days we used to have dead tank cities. Was um, that is like dead tank cities. It's your connection will be at the terminal voltage. The terminals are designed at the line voltage for the live tank cities. Okay, it's a older concept. Dead tank cities and all we are not using now.
Okay. Question from Robin Matthews. Sir, any opportunities for a fresher in JSW Toshiba?
Good question. So for that, we have to join HIW for our regular training. So we have many more companies like JSW and Toshiba. So definitely, we'll make sure you will be placed uh, in a respective position based on your interest and your communication skills.
Okay, there's a question from Rajesh. For what voltage levels we use PT and CVT?
CVT is generally used in the transmission system, like from 132 kV and above, we use CVT. And the CTs we use from low voltage application, like from 415 to 765 kV, we use current transformers.
Okay. Question from Shreyas. So what is ATS?
ATS.
Hmm.
ATS.
Somebody answer.
Full form?
ATS. I don't know what is ATS. Like it's not clear. In what terms he is asking the question.
Okay.
Automated transfer switch. Okay.
Can PT be replaced with another equipment? Question from Chaitanya Krishna.
So of
No,
course you can replace.
Okay. So which power is found at generating station? Either it is active power or reactive power. Okay.
It's an
Megamala.
apparent power only.
Okay, after
Okay.
yesterday's
Yesterday
class,
we
this
discussed
question
about
is really, yeah.
Yeah.
Okay, thanks for the question, Megamala. Could you please go back to the recording and have a look at it? What equipment substation are used to install a substation? Question from Giri Nayak. Maybe this is a long subject, Giri Nayak, where we will talk about details about substation and what are the equipments that are connected in substation. What are the mostly used breakers in high power transmission? Question from Shiva Ganesh. Mostly used breakers in high power transmission.
SF6 circuit breakers is used. Mostly the answer is question is not proper actually. So generally for high voltage applications, we go with SF6 circuit breakers.
Okay, Somnath asked a question, why do we use bus couplers in SLD?
bus couplers are for just if we incomer 1, incomer 2 and bus coupler. This will be the general schematic of the any switch gear. Incomer 1 will be coming from another source, incomer 2 will be coming from another source, and bus coupler will be there. Bus coupler always will be kept open. If any incomer fails, the bus coupler will close the bus coupler so that total entire panel will be energized. But that is the purpose of bus couplers. Just
Okay.
to connect, interconnect two bus stations.
Yeah, I request to all of you guys, please follow us in the LinkedIn and Insta pages so that for further updates, you will get all the next updates about our upcoming events and all through the LinkedIn. So I request you all to please follow us.
Yes, Jadhav, you can continue now. Thank you.
Hello.
Yes,
Yes.
Yes, sir. I have one question regarding MCCP. So, in most of the cases, like in village.
Can you please speak louder?
Hello. Yes. Most of the villages we are using MCB as a home applications. So, why do we not use MCCB and LCB there?
It depends on applications mostly
And
when it
also
comes
on the
to
load.
and fault level. Because if you take any distribution transformer, your fault level will not be more
No,
than
no,
5
no.
K.
In our home,
In our
Correct.
home.
Correct,
Sure.
Saurabh. Your question is right. See, basically, depending upon your domestic considerations, we see many parameters as in part of circuit breaker selection. Not only the current, not only the thing, as Madan sir rightly said, it could be the short circuit level, which we also consider.
Because if you check
And
your
also,
fault level at your home, it's not more than 3K or 4K if you calculate.
Yes.
so
So for
most of
that, MCB is sufficient. No need to go for MCCB.
and also the current that you're considering and the applications or appliances you're using at home could not be that high as in like in the industry. That is
Mostly
also
in
one more
your
thing.
home,
Yes.
you use like a 6 amps or 10 amps, or not more than 32 amps.
But sir, is there any restriction of a load to use MCCB or ELCB?
Especially you don't have MCCBs for single phase applications. MCCBs are generally preferred to go with 3 phase
Three-phase
applications.
application. Okay. And what about ELCB?
Sorry, MCBs are used.
ELCB,
MCBs are
ELCB.
available for 3 phase and single phase.
No. I'm talking about
ELCB.
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 See, the point is ELCB concept is again different because MCB doesn't have earth leakage protection.
Yeah.
MCB has only overload and short circuit protection. If to provide earth leakage protection to the system, MCB is coupled with ELCB.
Okay.
Okay, so that's where if there is any earth leakage conditions, ELCB trips the main MCB. That's where your system can be protected from the earth leakage conditions. So nowadays we have one more equipment called RC
RCCB.
RCCB. Now ELCBs
RCOB
are
like
discontinued. ELCBs are discontinued. No more using.
yeah.
RCCBs are in
RCCB.
working now.
Okay.
Yes.
There is like within everything is given within the breaker. Okay,
Yes.
residual breaker with the overload and short circuit condition like RCOB something is there.
Okay.
RCBO.
RCBO, yes.
Yeah.
Okay, sir. Thank you.
Thank you.
Thank you, Saurabh. Syed Anwar, you can actually unmute and speak up.
Yeah, before Syed Anwar unmutes himself and
Yes,
speaks
ma'am.
up, 1
Yes,
minute,
ma'am.
Anwar.
Please.
One
Okay,
minute,
ma'am.
Anwar.
Anwar, 1
Okay.
minute. I request all
Okay,
the
ma'am.
candidates not to share any screenshots or any photos in the chat box. Give their feedback, very good. But please do not share any kind of
Guys, you please
screenshots.
share your screenshots and in the LinkedIn so that people can understand and can know like there is some great sessions are going on from HIW. That would help to your friends and your subordinates. Okay, instead of sharing in the chat box.
Okay. Anwar,
So,
you can go ahead. Thank you.
and please
Yes.
tag HIW for that.
Yes. Good evening, sir.
Hi, good evening.
Sir, is the voice is clear?
Yes, you are clear, Anwar. You can continue.
So the small question is, sir, about fuse, sir. Whenever we see in our areas, in local areas, in distribution system, whenever fault occurs in the distribution three-phase wire or single-phase wire, the artisan or electrician goes on the transformer box. There is a circuit, there is a double circuit and single circuit. He removes the aluminum wire and put another aluminum wire. For
Yes.
not having that process, is there any process that automatic will be fuse will be hidden and what we call it will be ఆటోమేటిక్గా వచ్చేయాలి సార్ అది ఏంటంటే ఇప్పుడు అల్యూమినియం వైర్ పెట్టకుండా
See,
డైరెక్ట్ గా ఫాల్ట్ అనేది రికవర్
there is
కావాలి
no such kind of fuse. Fuse itself is a one-time usage device, Anwar. So if you want to, that's the reason to avoid that nuisance, breakers are introduced. Instead of using fuse, if you go with the breaker, then under faulty condition, your breaker will trip. You can reset the breaker again. You can reclose.
బట్ మెనీ
That's where.
ట్రాన్స్ఫార్మర్స్
Sorry.
but many transformers are not using the breakers on they are using
That
only
is
fuse.
because of economical condition. Because there, for example, 11 kV side, you cannot go with vacuum circuit breaker because your breaker cost will be more than your transformer cost.
Yes, sir. Thank you,
Okay.
sir. That's the
So,
question.
yeah. Thank you so much.
Thank you, sir.
Venkat Teja, you can unmute and speak up. You're there, Venkat Teja? Okay. Sriman Narayana, you can ask your question.
Good evening, ma'am.
Hi, good evening.
Good evening, sir.
Hi, good evening. You can continue.
Sir, I have a doubt in regarding transformers.
Sir,
Consider the two machines. One machine is 90% efficiency and voltage regulation is 10%, and the second machine is 85% efficiency and voltage regulation is 5%. Which machine has better performance? Please explain, sir.
I think you have this is a relevant question to the today's topic because the topic is different and your question
Sir,
is
so
different.
it is a general question asked in college. Which machine
In
has better
college,
performance? Yes, sir.
okay, your first motor is 90% efficient with the, can
And
you just
10% is
10%
voltage
regulation.
regulation.
10%
And
is the voltage regulation.
second machine is 85% efficiency and 5% voltage regulation.
Okay, so you want like see whatever the machine has lower voltage regulation is a better machine
Okay,
compared to
sir.
efficiency.
Okay, sir.
Because if but lower voltage regulation will have lower drop, so obviously your losses will be less.
Yes, sir.
Okay, so lower voltage regulation machine would be the better than higher voltage regulation.
Okay, sir. Thank you, sir.
Yeah, you're most welcome.
Teja, you can unmute and ask your question. Vaishnavi, you can unmute and speak
Sir,
up.
why we take voltage stability is more priority in transformers?
Why voltage stability is taken as more priority in transformers?
Because
Then
to give
efficiency.
quality power to the end customers.
Sir, in rotatory machines, we can take only efficiency or voltage stability more.
Both are very important. You have to maintain the efficiency and you should maintain the voltage stability.
In regarding question, for rotationary machines, which one is better, sir?
We cannot say like that which one is better, but both are important. Okay, but your voltage should be stable at the motor terminals and the motor should have better efficiency for the system.
Okay, there's a question from online, sir. Akhil is asking, in thermal power plant, which transformer is used most?
We
Which
use all the
transformer
transformers.
means?
We use power transformers, utility transformers, station transformers. So it depends upon the application. We generally take different transformers. Okay.
There's a question from Neeraj in YouTube saying how we decide ratings of CT.
CT ratings depends upon the connected load and depends upon the connected equipment across the secondary. If the meter is connected across the city secondary, we go with the metering core city. If the relay is connected across the city secondary, we go with the protection core city.
Vishwa, you can unmute and speak up with your question. Vishwa, you're there? Okay. Somnath, you can ask your question.
What is difference between smart breather and fast breather?
What is the difference between smart breather and? Yes, Somnath? Somnath, can you hear us?
Can you repeat the question again?
What is difference between a smart breather and actual breather? मतलब
Breather or breaker?
Is it breather or breaker, Somnath? Okay. Your question is not clear, Somnath. Sorry, we couldn't answer. Sanjay, you can unmute and speak up. Before Sanjay unmute us, there's a question from Shruti Jamdar asking about for earthing, we use mesh earthing for big system. Then what is the process for installing high rating substations? Okay. Maybe we can answer what is the type of earthing used in the power plants and a substation individually, sir. We can take this question like that.
For higher rating substations, generally we provide earth mat to drain the leakage currents effectively into the ground. So as such, we have no types of earthings and all as per IEEE 80. Okay, we generally go with the earth mat design for the substation to drain the fault currents.
Okay, guys, people have already got a chance to ask a question. I'm not unmuting them. Kindly post your question. Uday Kiran, you can unmute and speak up. You there, Uday Kiran? Sneha, you can unmute and speak up.
Guys, I have a request from you, like while filling your feedback forms, you please mention your college names so that we have to give the report to your respective HODs, like how many participants involved in this today's session from the respective colleges, guys. This is a request from your respective HODs.
Vinay, you can unmute and speak up.
Good evening, sir.
Hi, good evening, Vinay.
Sir, I have two questions, one for you, sir, and one for Banu was, sir.
Okay.
Sir, something is means normally we use transmission lines, no, sir. Means as the voltage increases, the conductor size decreases, no, sir.
Voltage
Because
increases?
Conductor size decreases, no, sir.
Okay.
Because the conductor size mostly depends upon the current carrying capacity.
Yes.
So, sir, normally in our local area, something like we use means for even for 11 kV line, the length cross section of the cable will be so small, no, sir.
Yes.
But whereas for 220 kV and 440 kV, we use bundle conductors, and that will be also quite thicker than the 11 kV cables, no, sir.
Yes.
So why, sir, we use means that thick
Its
conductor?
answer is very simple. It depends on current carrying capacity. At 220 kV level and 400
yes, sir.
kV level, the amount of current is flowing through the conductor is very high because that is we are using those conductors for the power transfer applications. Generally for 220 kV and all, we use like a moose conductor and a zebra conductor and all. Okay.
No, sir. Actually, they are the transmission cables, no, sir. So that after that,
It's not cable, it's a conductor.
yes, sir, it is a conductor. After that, the transformer will be placed. From the transformer, we will get the current, no, sir.
Okay. Of course, you are telling me correct. Okay.
So after the transformer, the cables will be quite means the thickness of the cable will be more, sir, because the current carrying capacity after the transformer will be more. But before it is a
Why?
transmission.
You're telling answer or you're asking question?
I am asking question, sir. That means primary side of the
In high
transformer.
voltage side, conductors not only depends on the current carrying capacity, that is also depends on the fault current also. That's why ST cables conductor size is not dependent on only load current. That is depends on fault currents. If you see motors also, even ST cables also for 200 amps cable, like the 630, 2 runs, 3 runs, like that will be there to compensate the fault currents, not full load currents. While designing ST cables and ST conductors, we need to take care of fault currents, not load currents.
Exactly. For HT applications, fault current plays the major role.
Okay. Thank you, sir. And also, sir, in thermal power plant, we use synchronous transformer, synchronous motors only, no, sir. Synchronous generator. That means.
Yes, synchronous generator.
For synchronous generator, normally the field winding is DC, no, sir. DC supply we provide, no, sir.
Okay.
For the DC supply, normally AVR from AVR we give DC supply, no, sir.
Yes.
So normally in a synchronous motor means we provide the supply to the primary winding. That means AC supply, and the DC supply will be coming from the AVR. But normally in the thermal power plant, the turbine, if the turbine rotates, the power will be generated, no, sir. So how can we control the supply from the AVR? Sir? Means both of them should be interlocked, no, sir. At one stage, when the North Pole and South Pole will interlock, the motor will be rotated, no, sir.
Actually, the excitation transformer will be there in between generator and wherever generation is from generator output is there. You might have seen in SLD before this, just before I have showed you. Where
Yes,
the
sir.
UT is tapped from the bus duct, from there only one more tapping will be there. That will go to the excitation transformer, which will further step down to the step down the voltage suitable for the AVR. That is special type transformers will be there, not like 415 volts, not like 3.3 kV.
Yes,
That
yes.
transformer will be designed for only excitation system, just like for example in our plant 800 megawatt, that 23.5 megawatt will be stepped down to 675 volts, and further that will be fed to the thyristor SCR control rectifier. From there
Yes,
the
sir, yes.
DC will be converted, so the DC voltage will be controlled by the firing angles of the thyristor.
Yes, sir, yes.
Okay.
Okay, what is the starter we use for the motors there over in thermal power plant?
Generally all DOL starter. Hello.
DOL starter, sir.
Can you hear me?
We use various starters, Vinay. Actually, we use DOL starters, soft starters, and star delta starters.
Yes, sir, normally
Depends on
DOL
the
starter
application.
we use only up to 5 HP like that only, sir. No, sir. But in thermal power plant we use
No, you cannot say that one. That is the how much capacity of source we have.
It's not like
If we
it's
have
not a standard like we
very
have to
small,
use DOL.
if we have very small source, we are not capable enough to give the static current. Then we will go for a star delta starter to reduce the static current. But industries very special purpose. If there is any very special purpose, then only they will use star delta. Otherwise, all are DOL starters.
Okay. Normally we use drives, no, sir, something like variable static frequency
That
drive.
is all the special drives in EOT cranes, like some DM plant motors, some sludge, some different applications are there. There only they will use, but all are only contactor controlled and breaker controlled.
Majority will be used DOL.
DOL.
Okay. Thank you, sir. Thank you very much.
Yeah.
Okay.
Guys, there are many people who have already raised hands. I'm not able to connect you. We'll take one last question. Alluri Venkatesh, can you please unmute and speak up?
Good evening, sir.
Hi, good evening, Andy.
Sir, in generation station, continuously the generation process going on, sir.
Yes, that depends on coal and demand.
Sir,
always that will be there. There is
sir,
yes.
if only the loads are present only at daytime, sir, what happened if no one is using many
No,
loads
you
on
need to
night,
shut
sir?
down the plant. That's all. If load is not there, you need to shut down the plant.
But it's not like that. Always your demand is more than supply.
Oh, okay, sir. Thank you, sir.
Yeah.
Thank you, Venkatesh. Thank you, guys. I see many other people raising the hands. Sorry, we will not be able to take more questions for today. Thank you, guys. Thank you, Bhanuas Garu and Manan Mohan sir for this. So it was a great interactive session today. Thank you so much. We'll see you tomorrow with our next topic on solar. Thank you, guys.
Okay, thank you very much.
Thank you all for your great patience and great interaction today. I request you all, please follow us for further updates in the LinkedIn and Insta. So you will get all the updates in electrical engineering. Thank you all. Good night.
Thank you, guys. Thank you. Please give your feedback, everybody. The link has been posted on the chat box. Yeah.